Okay, so for this one, we're going to locate the point in the coordinate system, draw a ray through the origin of the given point, choose the graph showing a single. So in this case, you'll have a selection, but we're not going to have a selection here. We're going to make it up from scratch. Showing the angle in standard position having the least positive measure. Then find the distance r. So basically what we're looking at is this, is you have an x and a y. And of course, in this case, that would be -6 over and -6 down, which would put you somewhere right in here. So what they're pointing out is that you have a triangle. -6 over and -6 down. And that the angle in standard position having least measure, in other words, just go from here to there. So this would be the angle that they're talking about. But most importantly, I'm looking at this triangle. And if I'm going to find this distance here, if I'm going to find this distance, which is what they asked me for, then find the distance r from the origin to the point. So from the origin to the point 6, 6. Sorry. Whoa, I want to do that. To the point -6, -6. Distance formula, Schmidt's formula, it's just Pythagorean theorem, which is all the distance formula is anyway. So in this case, if you see your right triangle, the r distance that they're talking about, that hypotenuse is just going to be the square root of -6 squared plus another -6 squared. And so r is going to be 2 times 36, that's 72, square root of 72, which is going to just turn out to be r equals 6 times the square root of 2. That's because that's just equal to 36 times 2, but the square root of 36 is 6, and of course square root of 2. So, this step here, though, finding that r, using the Pythagorean theorem, using this technique, the x squared, so the r value is just going to be, if you're looking for that, is going to be the x squared value plus whatever the y is squared. That is something we're going to use quite a bit coming up. All right, let's see what we have next. Okay, I'll do this one, but this is not one that we're going to focus heavily on. So a tire is rotating 720 times per minute. Through how many degrees does a point on the edge tire move in? Okay, so first of all, rotating that many times per minute. Well, every time it rotates, every time it does one of those 720 rotations, it is going 360 degrees. That's one rotation. So if I do 360, that's not what I wanted. This is. If I did 360, okay, we're getting there. How many times do you think I'm going to do that before I remember not to do that? All right, delete. So 360 times 720. That means the tire goes through 259,200 degrees per minute. All right, now that's great and all, but that's per minute. I need to divide that by 60 because I want to go from degrees per minute into, let's say, degrees per second. So I'm going to multiply this by 1 over 60, because in 1 minute, there are 60 seconds, and that'll get rid of the minutes and leave me with degrees per second. So we'll do 259,200 divided by 60 equals, that's 4,320 degrees per second, but I want to know how much is in a sixth of a second, so I'll divide that by 6 now. So that divided by 6 equals, so that is, well, interesting, 720 comes out the same number. That's just a coincidence in this case. 720 degrees in 1/6 of a second. Okay, we're going to pick up with this one in the next video. Thank you very much.